Here we go on section 8.7, simplifying radical expressions. Okay, so the main idea of this one is you want to be able to add, subtract, multiply with a comma there, and divide, and even simplify these radical expressions as well as rationalize in a denominator. There's a lot to do in this one. There's a lot to do in this one, so we might as well get started on this. Let's get started by how I can simplify radical expressions. Well, we've done things like this before. We just gotta get we gotta get groupings in there that match up with the index. Well, the index here, nothing's there, so the index is a 2. Remember, if nothing there is 2. So we're gonna break these up into pairs because this is 2. If there's a 3 there, we break it up into groups of 3. We want to find factors that are the same of groups of 3, and we're gonna pull those out. Okay, so let's ask ourselves. What times what is 49? Well, we know 7 times 7 is 49. We're going to break it up into the 7 to 7. We can do that one. And then we have this x squared. Well, that's like 2 x's, so we're going to pull out 2 x's right there. And then we have this y to the 5th. Well, that's like the square root of y times y times y times y times y, right? And we have the z to the 6th. That's the same as square root of z times z times z times z times z. Woo. Okay, I don't like how this one's going. That's a lot. That's a lot of work. Okay. What happened to my green? Times z again. Okay. Now, what we got to do is we're going to pull out pairs, 2 at a time. So, and when you pull them out, they become 1. So we're going to pull this out, and that becomes 1, 7. And then these x's, we can pull 2 x's out, and it becomes 1x. So we got the 7x, and then we can pull these 2 y's and those 2 y's out. Sadly, 1 y is left behind, right? So that will give me y times y. And then these z's, I got 1, 2, 3 pairs of z's to pull out. So that will be z times z times z. So what do we have left? Oh, don't forget about this. Remember this y right there? We still have that in there. So altogether we have 7x y squared z to the 3rd square root of y. That's our final solution for this one. It was simplified, all said and done. Okay, that's kind of like expanding. No, this is a lot of work to expand this. There's got to be an easier way. Well, there is. You know, you just kind of have to figure out that these are 2 x's right away, so you can take 2 out, make 1. This is, you know, the square root of 49 is just 7. This you can take 2 sets of y's out, and you're left with 1 on the inside. And this one you can take 3 sets of y's out, and you're left with just nothing, no z's on the inside. So I kind of showed you how to really break it up. You don't have to do that every time. Let's try this on the next one, okay? The quicker way. So let's figure out what's the cubed root of 27, or what to the 3rd power is 27. Well, we know that's negative 3, okay? And then here, well, we want to have groups of 3, so that would be 3 and 6, so we can bring x squared on the outside, but we're still left with 1x on the inside. And then we're going to bring a group of y's out there for that one. And you can't bring any z's out, so that's going to stay is. So our final thing, we have an xz squared on the inside, and there's your final solution for that one. All said and done right there for that one. So that's how you can simplify radical expressions. It takes a little practice, but I think a little hard work, and then you should have no problems doing this type of thing.